Hi everyone, this video is about the twin paradox. Let us first take a look at the Hafele-Keating experiment from 1971. The scientists Hafele and Keating measurements had the goal of experimentally demonstrating the time dilation predicted in the special theory of relativity. The two scientists took 4 very precise cesium atomic clocks with them on board aircraft. Another 4 atomic clocks remained on the ground. To illustrate, let's assume that the planes flew over the equator. Here we are looking at the North Pole of the Earth. In order to determine the speeds of all clocks, we choose a reference system that does not take part in the rotation of the Earth. We indicate this with an X. The clocks on the ground moved due to the rotation of the Earth. The speed with which these clocks move in relation to the reference system at rest is 463 meters per second. The red of the two planes flew eastward with the direction of rotation of the Earth. The speed with which these clocks move in relation to the reference system at rest is 685 meters per second. The blue of the two planes flew westwards against the direction of rotation of the Earth. The speed with which these clocks move in relation to the stationary reference system is 241 meters per second. Now, the special theory of relativity says that moving clocks go slower due to time dilation. The faster the movement, the slower the clocks go. Consequently, the clocks of the red plane should be the slowest and the clocks of the blue plane the fastest. However, since the planes are also further away with the center of the Earth, a lower gravitational force acts on them than on the clocks on the ground. The general theory of relativity says that clocks move more slowly under the action of gravity. The greater the gravitational force, the slower the clocks go. As a result of this effect, the clocks in the aircraft would have go faster than the clocks on the ground. After long flights around the world, the two planes landed again at the floor clocks. The scientists then took the times of the 4 respective clocks and averaged them. The clocks on the floor indicated the elapsed time on the floor. The clocks of the red, faster aircraft went back an average of 59 nanoseconds. The passengers on this aircraft have aged 59 nanoseconds less than the people at the ground station. The clocks of the blue, slower aircraft went an average of 273 nanoseconds ahead. The passengers on this aircraft have aged 273 nanoseconds longer than the people at the ground station. What happens if you carry out this experiment again but use a spaceship instead of an airplane, and this does not move at 700 meters per second but at 80% of speed of light? Let's look at that. Philip and his twin brother Tom want to find out. Philip flies to another planet and back in a spaceship at 80% the speed of light. After 10 years measured from the Earth, it turns around and flies back at the same speed. From Tom's point of view, Philip moves very quickly. Tom assumes that time passes more slowly for Philip because of the time dilation. He believes that Philip will be younger than him when he lands. From Philip's point of view, the Earth moves very quickly first away from him and then towards him. So he believes that Tom's time will pass more slowly and Tom will be younger when the spaceship lands. This is paradoxical because there can only be one result. Just like in the Hafele-Keating experiment, the red plane first accelerates and then decelerates, accelerates and brakes Philip's spaceship. This means that the clock goes slower for Philip than Tom. The big difference to the Hafele-Keating experiment lies in the acceleration of the spaceship to 80% of speed of light. As a result, the time difference is not just a few nanoseconds. If Philip lands after 20 Earth years, Tom has become 20 years older. For Philip, however, only 12 years passed.